Hello folks, in this video we are going to present to you a novel type of magnetic rotary position encoder. These encoders are typically composed of a magnet with a specific pole pattern and a sensor with all plates which detect the varying magnetic field when the magnet rotates. Here is what you can find today on the market. On one hand, you have the low-cost systems with a simple dipole magnet. These systems typically reach about 10 bits of accuracy and 14 bits of angle resolution. On the other hand, we have a much more accurate, but also more expensive system. Here, the magnet has a very complex multiple structure. Such systems are typically specified to 14 bits of accuracy and 18 bits of angle resolution. So you can see there is a large performance gap between those two solutions, and with our novel system, we exactly want to bridge this gap. This is the Melexis solution, a compact magnet with two tracks similar to the high accuracy system, but with fewer and much larger poles, well adapted for low-cost, high-volume production. A very small CMOS integrated sensor with all elements is used to pick up the magnetic patterns of the two tracks. This system provides an angular accuracy of 12 bits and an angle resolution of 16 bits. The use of such larger magnetic poles is only possible if the sensor is pole pitch independent. This is the case for our sensor, which due to the triaxis technology is able to measure the magnetic field in more than one direction, and in a single point. An advantage compared to other available systems which measure the same parallel components in at least 4 different spots. The larger poles also generate a stronger magnetic field, allowing for more air gap between sensor and magnet. This makes the Melexis system much easier to assemble without fine adjustments and robust against dynamic wear out. We built this demonstrator to show you the performances of our system compared to a state-of-the-art high-accuracy encoder. In the next section, we will show you the different parts of the system. The actuation of the demonstrator is done using a very standard stepper motor, with an additional gearbox with a reduction ratio of 26. On this motor has been mounted also a PCB which drives the motor and the rest of the electronics. Now we mount the reference magnet. This one is very different from ours, with more than 100 poles and a very fine stepping. It requires a lot of calculation power to retrieve back the angle information, and the PCB is quite rich of components and power consuming. Notice also the very small air gap required for the system to function correctly, which complicates the overall assembly. Finally, we mount our system. We place our sensor at around 1.5 mm air gap without measuring it precisely, and we are ready to go. Now the demonstrator is complete, and we can analyze its accuracy and noise performances. After calibration of some algorithmic parameters and some data points in a lookup table, we make a test run of the magnet. In the left plot, you can observe the angular position measured by our system versus the position measured by the reference system over the full 360-degree range. On the right graph, we plot the difference between the measured angles of both systems. Next to the accuracy, the resolution is also an important performance parameter. Here, on the left, we measure it for both systems by the noise level in a static angular position. On the right-hand side, you can see the distribution plot of the measured accuracy, indicating the resolution in bits. We can see that our system reaches a resolution of 18 bits, equivalent to 1/1000th of a degree. Now, what can this novel rotary encoder be used for? Where will it really make a difference? As we have seen, Melexis' solution operates at a significantly larger air gap and with a small magnet compared to the high accuracy systems on the market. At the same time, it is way more accurate than the simple low-cost systems. This concept is therefore well suited for applications like robotic joints or motor control systems, where the air gap between the magnet and the sensor can change over lifetime. Thank you for your attention, and see you soon.